This final topic dealing with lines is all about applications. Now we touched on this a little bit when we did intercepts and slope because we got into this whole idea of um, y-intercepts being starting points generally and slopes being rates of change. But here we're actually going to formalize it a little bit more even. All right. So there's basically going to be two kinds of problems that you can get with these um, linear function application problems. One where you're given the equation and then you have to basically answer questions about it, and the other one where you're given just some information and then you have to create an equation from that information. So if you remember, generally we had said in an application problem, the y-intercept is normally going to be your starting point, right? Or your initial value of the uh, of the function. And we had also referred to slope as a rate of change and tied specific units to it. So like I say, that's going to be the main focus of this section here. So let's look at this first example. So a Metro card has a value of $45. So right there, that kind of gives you the initial value. Each ride on the subway costs $2.25. And the equation that gives the amount of money remaining on the card is y equals 45 minus 225x, where x is the number of subway rides and y is the value remaining on the card. So what are the slope and y-intercept in this equation, and what do they represent? And then find the x-intercept, and what does the x-intercept represent? So right there we had identified the $45 as being the initial value. We can also represent the 225 as the cost per ride. So since that's the cost per ride, it should make sense that the equation y equals 45 minus 225x models this situation, right? Because 45 is the initial value, that's the b, the y-intercept, and the 225, it's really negative 225, right? Why is it negative? Because y is the amount remaining on the card. So each time the card is used, the value goes down by $2.25. So right there, what I just kind of said are, the meanings of the slope and the y-intercept. But let's write it out a little bit, right? So we'll call this part A, right? So the slope is negative 225, and what that's saying is each use of the card lowers the value by $2.25, right? Or you could say something like each ride costs 225. But you wanted to specifically say why it's negative, and that's the whole idea of lowering, right? So that's where the negative comes from. So that's the slope, and the y-intercept was $45, well 45, so we can say the initial value on the card was $45, right, before any uses were made on it. Okay, so that's the slope and y-intercept and what they represent. And then the x-intercept, remember, how do you find an x-intercept? We'll call this part B. To find an x-intercept, you always just set y equal to 0. So when we do this, the equation that we solve becomes 0 equals 45 minus 225x. So if we subtract 45 here, we get negative 45 equals negative 225x. And then we would just divide by negative 225. And we're going to find that x equals, what is that, 20? 20. So the x-intercept is actually going to be the point 20 comma 0. So what that would mean in this case is after 20 uses or rides, whatever you want to call it, the Metro card is empty, right? It has $0 left on it. So we can just say it's empty. So that would be the meaning of the x-intercept, right? So the x-intercept in a lot of these cases is kind of like the ending point, right? The y-intercept is the starting point, and the x-intercept is like the ending point. Continuing now, we have another example that again gives us the equation, and we have to answer questions that basically are interpreting what the equation means. So in this case, we have a mountain climber camped out at an altitude of 6,000 feet. So if they're camped out there, that's going to be the idea of this initial value or starting point, right? So this is like your initial altitude, or you could call that the y-intercept, right? That's going to be your initial value. She begins her ascent up the mountain. So she's going up and is climbing at a rate of 300 feet per hour. So this is going to be your rate of change. And again, rate of change was slope. So there's your rate of change. So then the equation, not surprisingly, is y equals 300x plus 6,000 plus 6,000. This gives her altitude y after x hours of climbing. So again, same idea. Interpret the slope and y-intercept. So the slope was 300, and again, remember it's a rate, feet per hour. So what this means is you can't just say 300 feet per hour. You have to, be more specific and say she is climbing at a rate of 300 feet per hour. So that's the slope, and the y-intercept in this case was 6,000. So again, that's her initial altitude or her starting altitude. So you say she started out at an altitude of 6,000 feet. And then in this case now, if we try to think about the x-intercept, well, what's the x-intercept going to be? It's again the value of x when y equals 0. So we would have to do 0 equals 300x plus 6,000. So we would subtract 6,000 and then divide by 300. But 6,000 divided by 300 is actually going to be, in this case, a negative 20. And since x is time and hours, it doesn't make any sense, right? So it really has no meaning in this case. And why does it really have no meaning? Because you can't have negative time, basically, right? The idea here is she's not going down the mountain, she's going up the mountain. So it might, what would make more sense in this case is a question such as, how long will it take her to get to an altitude of, 10,000 feet or something like this, right? That's a more logical question because she's going up, she's not going down, right? If she was going down, it would make sense, but in this case, she's going up.